नेपाली प्रोडक्टहरूलाई भनौँ न प्रोत्साहन गर्ने भन्ने किसिमको कुरा भयो। तर अब फेरि कन्ट्र्याक्टरको आफ्नो चोइस पनि हुन्छ। अब कन्ट्र्याक्टरको इच्छा चाहिँ इन्डियाबाट ल्याउँछु भन्ने थियो होइन। त्यो भएर यो समयमा चाहिँ अलिकति केही समय लाग्यो डिसिजन हुनको लागि र अहिले हामीलाई 900 मेट्रिक टन चाहिनेमा 300 मेट्रिक टनको लागि चाहिँ उहाँहरूले अनुमति पाइसकेको अवस्था छ। जो सबैतिरबाट सपोर्ट नै छ भनौँ। अनि इक्विपमेन्ट्सहरू पनि अलमोस्ट 90% भन्दा बढी नै इक्विपमेन्ट्सहरू साइटमा आइसकेको अवस्था छ। त्यसै गरी रिजर्भर ट्याङ्क्सहरू पनि बनाउने क्रम जारी छ होइन। गार्ड हाउसहरू त्यो अफिसहरू रिजर्भर ट्याङ्क्सहरू अपरेट गर्नको लागि अनि वाटर सप्लाई लाइन्सहरू त्यसै गरी पोर्टल प्रिपरेसन अनि अप्रोच रोडहरूको काम भइरहेको छ। अनि रोड साइड सर्भिस सेन्टरको काम भइरहेछ। अनि बङ्करहरू हामी इस्टाब्लिस गरेका छौँ 3वटा ठाउँमा। इस्टमा 10 मेट्रिक टनको, वेस्टमा 10 र थानकोटको आर्मी क्याम्पभित्र 40 मेट्रिक टनको चाहिँ बङ्कर इस्टाब्लिस भएको छ। र ओभरअल प्रोग्रेस चाहिँ नि अहिलेसम्मको फिजिकल प्रोग्रेस 5% छ। अब टनल नै कति मिटर खनियो त भनेर भन्दाखेरि चाहिँ टनल खन्न सुरु भएको छैन होइन। अलिकति इफेक्ट चाहिँ नि कोभिडले पनि गर्यो। र अर्को कुरा चाहिँ हाम्रो यो टनल एक्सपर्ट्सहरू भनौँ न, टनलकै मेन कोर टिमहरू चाहिँ अब योभन्दा अगाडिको लकडाउनमा जापान फर्केको हुनाले उहाँहरू फिर्ता आउन सक्नु भएको छैन। अब होपफुल्ली यो एक्सप्लोसिभ मटेरियल्सहरू पनि सेप्टेम्बरको एन्ड अथवा अक्टोबरको फर्स्ट विकसम्म नेपाल साइटमा आइसकेको हुन्छ। र त्यति बेलासम्म यो टनलको टिम पनि आइसकेको हुनाले सेप्टेम्बरको एन्ड अथवा अक्टोबरको एन्डदेखि चाहिँ हामीले खन्न ड्रिलिङै मेन त्यो टनलको ड्रिलिङै गर्नलाई सुरु गर्ने भन्ने प्रोग्राम छ। अब यो केही फोटोहरू साइट्समा यो चाहिँ वेस्ट पोर्टलको प्रिपरेसन भइरहेको फोटोहरू हो। अनि यहाँ जेनेरेटर्सहरू पावर सप्लाईको लागि। त्यसै गरी यो चाहिँ मेन ड्रिलर हो। यसको नाम चाहिँ जम्बो ड्रिलर भन्दो रहेछ। यो ठ्याक्कै यो इभ्याकुएसन टनलकै पोइन्ट हो। यो यहीँबाट हामीले ड्रिलिङ गर्छौँ। यो त्यसको फोटो भयो। अनि ब्याचिङ प्लान्ट यो इस्ट पोर्टलमा इस्टाब्लिस गरेको कन्क्रिट ब्याचिङ प्लान्टको फोटो हो। त्यसै गरी यो चाहिँ रोड साइड सर्भिस सेन्टर अनि यो टिनको निलो टिनको छानो भएको बिल्डिङहरू यो चाहिँ टेम्पोररी हो। एक्सप्लोसिभको जति पनि कामहरू गरिन्छ त्यसको ट्रान्सपोर्टेसनदेखि लिएर त्यो पड्काउने समयको काममा सबै काममा नेपाल आर्मी इन्भल्भ हुनुहुन्छ। उहाँहरूको क्लोज कोअर्डिनेसनमा उहाँहरूको निगरानीमै हुने भएर यो चाहिँ नि नेपाली सेनाको लागि बस्नको लागि चाहिँ बनाइएको हो। यहीँनिर एउटा बङ्कर पनि छ। यो उहाँहरूको लागि यो पछि डिसमेन्टल हुन्छ यो काम सकिसकेपछि। त्यसै गरी यो चाहिँ इस्ट पोर्टलको प्रिपरेसन गरिरहेको फोटो हो। अनि यो चाहिँ रिजर्भर ट्याङ्कीको रिजर्भर ट्याङ्क्सहरूको फोटो। ओके, मोटामोटी मैले भन्नुपर्ने कुराहरू यति नै हो। र अब केही त्यस्तो जिज्ञासा केही क्वेसनहरू छ भने फेरि क्वेसन एन्सर राउन्डमा हामी भेट्नेछौँ। Over to you, Kushalta.
Okay. Thank you, Kalpana ma'am, for your wonderful presentation. It has made most of the things clear to us about the tunnel project and its progress at present as well. I'm sure there are several questions to you, as we can see some of the queries in question answer box as well, but we shall be taking all those questions during the question answer session afterwards. Thank you again, ma'am. So now our second invited speaker is Mr. Yasuhiro Nozue from Nippon Koei Company Limited of Japan, and he's representing the consulting engineers of this tunnel project. Mr. Nozue, a Japanese national, is a civil engineer by profession and an expert in geology. He has a bachelor's degree and a master's degree in civil engineering from Waseda University, a high-ranked private sector university in Japan. He has been with Nippon Koei Company Limited for the past 23 years. In this long professional career of Mr. Nozue, he has worked in different countries of Asia, Africa, and Latin America for 9 years, focusing on geotechnical investigation and evaluation, planning, basic detailed engineering design, construction planning, and research in the fields of tunnel, dam, road and bridges, and seaport and airport projects. He is a registered professional engineer of Japan and a member of Japan Society of Civil Engineers, Japanese Geotechnical Society, and ASTM International as well. With this introductory note, I would now like to pass the floor to Mr. Nozue for his presentation. The mic is over to you, Mr. Nozue. You have about 35 minutes, sir.
Thank you. Thank you, Miss Kushalta. Thanks for a nice introduction for me. Good afternoon, everyone. Namaste. I'm Yasuhiro Noze, civil engineer, Nippon Kore, Tokyo. I really appreciate for inviting this meeting. I'm really happy to speak about our project today. Today, I would like to introduce some technical features of Nagdhunga tunnel construction project. Sorry. This is today's content. So before Ms. Kalpana-san explained about our outline of the project, so I will skip, but anyway, our planned tunnel is about 2.67 kilometer length. It's first road tunnel in Nepal. This is a typical cross section, so it's mean about 3.5 one lane by both directions, plus shoulder and center line or something like that. So in totally about 11 meter width of the tunnel. So from now, I would like to enter in some more specific issues regarding tunnel construction project. Actually, for realizing the project, we need to study carefully, know well the condition and solve the technical issues, if any. Firstly, geological features. So this map shows the tectonic plate on the Earth. So you can easily find our countries. So Nepal and Japan are on the border of the plates. So very similar condition, you know. So like this collision activity of the plates formed our ground, and the activity strongly affect to the geology of our countries. This is the Nepal and Japan geological map. So as activity of the tectonic plates formed our ground, we can find similarly on the geological condition of both countries. We can find both countries geological complexity, lineaments, faults, periodic fatal earthquakes, and so on. The condition, our geological condition is very different from other countries with stable geological condition. For example, Euro countries, African countries, and Central American countries. China also are very stable. Their countries on the center of the plates. So we think many Japanese experiences of tunnel construction projects can contribute development for Nepal construction technology. And for planning this project, we apply Japanese design standards. But like these three standards is one of the major standards in Japan. So considering these complexity of the geological condition in the design stage, detailed design stage, we conducted the geological investigation in detail. This map shows the location of geological investigation for the project planning. We conducted 7 vertical boreholes and 1 horizontal borehole, micro-tremor array measurement, electrical resistivity tomography, and seismic refraction tomography. This is the location of each investigation. So this is a sample, core sample of 1 borehole. So this is the number VB, so vertical borehole number 3. So this borehole excavated to the depth of 180 meter, very deep, so long. And here's lead marking. So 166 to about 175 is the depth of tunnel alignment. Around here, RQD value is almost 100, near 100, so that it means we can determine the rock condition is almost good. Little risk during excavation. And this is the micro-tremor array measurement. So for figuring out the geological condition continuously along the alignment, we conducted other investigations, not only a borehole survey, but also some investigation methods can obtain the continuous information. It's one of the like that investigation. So this is result of micro-tremor array measurement. The investigation can figure out P wave velocity under the ground, so we can grasp hardness of the geological formation on the tunnel alignment. Next one is seismic refraction tomography results. Adding other investigation results, we got some more information. Through this investigation, we found some low velocity zone on the alignment. So it's one of the potential risk zone we determined. So we need to excavate carefully for safety construction or passing that area. So in this results, so the green one is a low velocity zone. So according to these investigation results, we identified the formations, the structure of the target area geology. So also faults, unconformity, and fracture. So it means a weak geological structure on the tunnel alignment from the point of engineering view. And then we summarized the results like this. So here is the tunnel alignment, and this green tuff is the weak zone. So along the tunnel alignment, we carefully determine the hardness of geological condition. In this legend, so left side, C1, you can see C1, C2, D1, D2. So it's divided by the velocity of wave, wave velocity. So C1 is harder than the C2 or D1 or D2. D2 is the weakest in this area. So, for constructing safety, so excavating safety, excavating this tunnel safety, we need to take most care of most take care for passing that. But in this drawing, D1 or D2 section, we need to more careful attention. As you know, and the important points, as you know, the geological investigation can be conducted at limited points. So we have to note that this assumption, our assumption, this geological profile contains uncertainty, some unclear things remaining, some uncertainness. We also summarize the geological profile at the both portals like this. Column layer is a bit thick at east portal under the slope. So next, construction method. For the tunnel construction, we applied NATM, New Australian Tunneling Method, auxiliary support, and full-face excavation. NATM is one of tunnel excavation methods. The phenomenon is a little bit unique comparing other civil works. So with expecting ground arching action as main support for tunnel stability. So this is what's NATM. So NATM consists of basically shotcrete, lock bolts, and steel rib. Detailed specification such as number, area, spacing of rock bolts and steel rib is determined adjusting to geological condition. So some section is very hard and some section is little bit weak along the tunnel alignment, so that we need to adjust the support type specification to the actual geological condition. It's one of the important points of NATM construction. Please see the videos showing the sequence of this method. So firstly, shotcrete concrete is, and then lock bolt will be installed here. After that, this installation, after this installation, steel ribs are placed like this, and then lining concrete will be poured like this. this circular form is the form for pouring concrete. So for pouring, please see this. So from the window or the equipment is placed like this. This is the actual vibrator for concrete compaction. So this is a pouring concrete pipe, and pouring concrete, and during pouring concrete, the vibrator will be pulled by the workers like this. Manual, but it's very important. You can understand the tunneling construction is like this lining concrete covered the original geological ground, so that the avoid cavity and the lining concrete layer is significant for ensuring stability and durability after completion of the tunnel. That's why the careful compaction is very important for keeping the quality. So this table shows the detailed specification of NATM support patterns. So for example, please see this table of peripheral spacing of rock bolts. So C1 type shows 1.5 meter, and D1 type is 1.2 meter. It means more, much number shall be installed in D1 type than C1 type. Like this, and the NATM construction support pattern is selected for keeping the stability with adjusting the geological condition. This is a typical cross-section of each type of support patterns. We can see much more rock bolts and thicker shotcrete layer in D type than C type. Please, sorry. Please see here. This is also important. So for weak geo sections, so for D type D sections, the bottom slab, we said this invert concrete is planned for improving the structural stability. So our next topics, the challenging issue at West Portal. So West Portal is planned just under the existing Tribhuvan highway. So from the surface of the road to top of the tunnel is only 6 meters. So during construction, the road is in service, thus ensuring safety, keeping stability as the most important issue in the project. Keeping the stability, we planned auxiliary method, and we conducted the 3D FDM, meaning finite difference method, for figuring out the behavior of current slope, including existing load. This is the model of numerical analysis, and the cases for alternative study with changing the excavation patterns. First one is a long bench cut, so up to top to bottom. Sorry, case one is a bench cut method. So from top of the tunnel to firstly about half advanced excavation will be done, and then the lower half will be excavated. The case two, full face excavation. So one time full face, almost all from the top of the tunnel to bottom of the tunnel will be excavated almost one time. And early close of the tunnel invert, the bottom slab concrete, early closure can be done for one time excavation. So case one and case two. This is the prediction of settlement on the ground after excavation. From this comparing allowable settlement, we selected the appropriate construction method. So this means this left side drawing shows settlement. So about minus 10 meter settlement subsidence will be occurred around this blue area. So case one like this, case two like this. So comparing these numerical analysis results, we selected the method. The selected is the full face excavation and early closure of the invert by the invert concrete. So this early closure type of the construction, and also we applied the floor piling with grouting near the portal area like this, and also face bolt for improving the strength of the ground. This is a typical cross section near the portal section. So you can see many lock bolts and around the crown, top of the tunnel, many floor piling. It's grouting pipe and grouting method. So you can see more robust structure than the type in the middle section. Yeah, today's summary. Complex geological condition in Nepal and Japan, we conducted a careful investigation for figuring out these conditions. Then construction method, the basic idea of NATM, and we selected the support type to keep the stability with adjusting the geological condition I explained. Last one is west portal construction. We carefully studied and selected the technology for ensuring safety during construction. Yeah, end of presentation. Thank you very much for careful attention to my presentation. When I will now, also in Japan, the COVID situation is a little bit bad, but now a little bit improving in Tokyo situation. When I will get the visa and flight ticket, I will go to the site, Kathmandu, for construction supervision and do my best for project success. Now I'm looking forward to see persons in Nepal. Again, I appreciate for giving me this opportunity. Dhanyavad.
Thank you very much, Mr. Nozi. That was a great presentation, and I hope all our audience has found it to be much informative. Thank you again, sir. As I mentioned earlier, we shall take the questions in the question answer session later. Now we have 3 commentators whom we have requested for their brief and specific comments on the presentations made by our invited speakers, as well as on the general aspects of tunnel building in Nepal. First, we have Dr. Gangalal Tuladhar, who hails from Dhading district and serves as a politician. He has been a member of Parliament of Nepal for 2 times in the past and also a member of the Constituent Assembly of Nepal. Some 8 years ago, Dr. Tuladhar served as the Minister for Education and also looked after a few other portfolios. We have invited him to the program as a commentator since the preliminary decision to build this Nagdhunga tunnel was made by the cabinet of his time. So Dr. Tuladhar will share us today some of his experiences about the government's decision to go for this tunnel. Dr. Tuladhar, the mic is over to you, sir. You have about 6 minutes for the comments, sir.
Thank you very much, Kushalta. Mr. President, Professor Netraprakash Bhandari, presenters, commenters, participants, good afternoon, everyone. It's my great pleasure to be here in this special webinar and also an honor to share my experiences on Nagdhunga Roadway Tunnel project. I would like to share some experience on how it was possible to implement this very new and the first roadway tunnel project in Nepal. In fact, I know Japan's 70% of the land is steep mountainous with great geological variation. In this regard, tunnels are playing an important role to develop new road road network, and the number of road tunnel in Japan has continually increased rapidly over many years. Because of the recent development of road network through mountainous terrains, and also because of the modern tunnel construction technology, tunnels have been adopted as an increasingly cost-effective engineering solution to cross urban areas with minimum local environmental impact. It was my first impression towards Japan. I was really excited and very eager to implement in Nepal as soon as possible. Keeping these facts and lesson learned by visiting and observing various tunnel roads projects in Japan in mind, I realized that Nepal is still lagging in infrastructure development, especially in road networking. Being situated at the foothills of the Himalayan, with a complex geological location, Nepal is covered with steep mountainous terrain. Since 80% of our country is mountain regions, road construction and maintenance experiencing huge costing, resulting in very slow progress. Therefore, as a Minister for the Education and a spokesperson of the government of Nepal in 2011, it was the real opportunity and prime time that I convinced Right Honorable Prime Minister Jhalanath Khanal and the cabinet. The cabinet became fully convinced on the urgency and need of tunnel road construction project in Nepal as being only trunk road which connects capital to the rest of the country. We identified Nagdhunga Pass as an appropriate tunnel road project to be implemented. Thus, the cabinet decided to endorse as an only one and first agenda of the first meeting of the cabinet to construct a tunnel here and believe that it could be a model of other tunnel projects to be implemented in future. It will definitely a model project which is based on technology transfer principle. The universities, professors, researchers, and students will be benefited from this project as well. I wish the quick and timely completion of the project. Thank you very much.
Thank you, Dr. Tuladar, for your experience and excellent comments. We very much appreciate that you shared your experience as a former cabinet minister and a local of that area. Thank you very much, sir. The second commentator is Dr. Pawan Kumar Shrestha from Hydro Tunneling and Research Private Limited, Nepal. He is a civil engineer by profession and has a bachelor's degree from Tribhuvan University and a master's degree in hydropower development and a PhD in engineering geology from Norwegian University of Science and Technology. He has been involved in planning, design, and construction of hydropower and underground structures in Nepal for the past 24 years. So now the mic is over to you, Dr. Shrestha. You have about 6 minutes for the comments.
पवन सर तपाईको माइक म्युट भएको छ सर.
Oh yeah, sorry. So thank you very much. So it has been my pleasure to be here in this webinar where we are discussing on our future, particularly in terms of road tunnel in Nepal. So which is quite has a significance in driving our country to the prosperity. So we obviously know that why do we need road tunnels? Ms. Kalpana has already expressed, presented the benefits and challenges. So I would rather, say that, Nagdhunga Tunnel is a pilot project in terms of, standardized road tunnel. So we have had a lot of, road tunnels in Nepal since for the last couple of decades. We have, improved a lot of, tunneling, technologies. We have excavated about 250 kilometers of tunnel in Nepal. And but in terms of road tunnels, we don't have systematic road tunnels, but some tunnels which are equally good, like the one being operated in Middle Marsengdi, which is in good operation. So those are project-specific tunnels, road tunnels. But we are now here entering into standardized road tunnel. So we, in addition to this Nagdhunga road tunnel, so we have planned a lot of other road tunnels. But the current future, nearest future is the Kathmandu Mades road tunnel, which has two twin tunnels for bi-directional, transport movement of vehicles, and we'll have about total 12 kilometers, both sides altogether, total 6 kilometers, but but due to bi-directional movement, two twin tunnels, it will be about 12 kilometers, having the longest being about 3.3 kilometers. So we are now entering into this road tunnel development phase. But what are our challenges? Benefits, we obviously know, our country is a mountainous country, so we need to have, connectivity between two, endpoints. And then we have to have, shorten, travel distance, avoid winding routes. The terrain, the topography is challenging a lot. We cannot have, express routes or better routes with high, grade of high gradient. And then we have a lot of, other challenges, surface challenges, like the landslides and other, socio-environmental issues. So like a case maybe the Siddha Baba Road Tunnel, where, we want to have a bypass of the, the landslide prone area. So benefits there are many other benefits, But the challenges are there, particularly, the geological conditions here. We need to consider, we have to design our tunnels in terms of understanding geological condition. And then our capacity enhancement is also there, the challenge is there. So Nagdhunga Road Tunnel particularly, I can see presentation by Mr. Yasuhiro that, there have been, comprehensive investigations being done there. About, I guess, I assume, it is about the length of ERT divided by length of the tunnel is approximately 2, so which is quite good. So, comprehensive investigations have been done. The method, we have a lot of, excavation methods. The designers have proposed Japanese standard method of tunneling. So that is okay, NATM, that is basically based on the NATM method. We have, but prior to that, why will we need, what is the standard method of designing road tunnels, defining the dimensions, requirements? Those are based on the traffic volumes. So Ms. Kalpana told a while ago that, it is about 13,000 annual average daily traffic. That is the basis for designing the Nagdhunga road tunnels, which is exceeding the requirement of 10,000 for 10,000 AADT. So that meets the requirement. So in there we have other tunnels being planned, road tunnels being planned, where we may hardly have that much of traffic volume. But there are some other issues. Strategic economic benefits are better than have a better control or requirement than the one being done at Nagdhunga. So what I see is that possibilities, there are a lot of benefits, and then a lot of the future is ahead. And I wish Nagdhunga Road Tunnel proved to be a very good example and give us a good insight of not only tunneling. We are actually have capacity to some extent that we can now excavate tunnels of span up to 11 meters, which is being excavated in Arun third project. So that the geological condition there is also not that good. So there is no, definitely there are challenges, but we should not get afraid of the situation that we cannot excavate this large tunnel or this or that. It's not. The technologies we are gradually improving our knowledge, so we can also procure. And the importance is in technology transfer, like particularly the safety requirement in the road tunnels, and then the operational mechanism, the installations, those things. We need technology being transferred to Nepal from abroad. I really wish Nagdhunga Road Tunnel be successful, and will also establish a good standard, and then so that it will be success of it will give us good confidence that we now can enter into the road tunnel era. Thank you very much.
Thank you very much, Dr. Shrestha, for your comments and for highlighting some of the challenges in tunnel construction in Nepal. Finally, we have Professor Krishna Kanta Panthi, all the way from Norway, for the comments. Professor Panthi is currently affiliated with the Department of Geoscience and Petroleum of Norwegian University of Science and Technology. His fields of research are engineering geology, tunneling, hydropower, and mining engineering, and he's currently involved with research projects on long-term stability issues of waterway tunnels in hydropower projects, project management and geological risk, high pressure online and shotcrete aligned hydropower tunnels, stress-induced instability in tunnels, and rock slope stability issues for both pit mines and civil engineering. Now I would like to kindly request Professor Panthi to proceed for his comments. The mic is over to you, sir. Professor Panthi, sir. You have about 6 minutes for the comments, sir.
Thank you very much, and namaste, everybody. It's my great pleasure to listen the presentation from the previous speakers and comments. So, after looking the design which is here, the traffic volume is estimated of 13,000 vehicles per day, and with the cross section given here, so with this evacuation tunnel, so I would have preferred to have 2 tubes tunnel here because the traffic is too huge here, and especially when it comes to the safety of the requirement. So, and anyhow we have to make this small tunnel for the bypass, so it would have been extended and made as a parallel to tubes tunnel to have a better safety of the conditions here, because cost will be almost similar. So if we had a system like this here, so 2 tubes tunnel and in between some connection tunnels, then it would have been much safer to drive through, because the tunnels are steeply downhill. So, and anyhow we have to have this evacuation tunnel, so it would have been extended to have a parallel tube. In my opinion, it would have much increased the safety standard much more than the at present instance. So because there will be, in a rush hour, there will be over 400 500 vehicles in this tunnel, and if suddenly something goes wrong, so then stoppage will be there, and there will be a suffocation, quite a lot of exhaustion, and then people has to be evacuated and vehicles have to be evacuated. If it was a 2 tubes tunnel, it would have been much easy to handle. So it's a very important and national project. So when we decide to invest and to make such improvement of the infrastructure, we should look on the long term. This is the major concern I have. So the road department should have looked little bit more critically and looking on the future, because this is the most important highway to Nepal, which brings people, materials, equipments, everything through that to the Kathmandu Valley. So if there is an accident inside the tunnel, so then it will take very long time to evacuate people and the vehicles. Even though there is a small margin to bypass the traffic, but still the pollution extent will be quite considerable because of this. So there will be a stoppage of vehicle movement that will make huge impact. So I would have considered to have 2 tubes tunnel here. So I think my recommendation is that the government still thinks, and then instead of having this evacuation tunnel, it would have been changed to the 2 tubes tunnel. And of course, there will be some additional cost for that, but still that Nepal can afford by itself from internal funding. I think if it is not possible to get from soft loan from Japan. This is my major comment with this tunnel. And then there are some, of course, alternative things. So like geology, I think in this area, the rock is mainly meta sandstone and phyllite. So which is a fairly good rock, and it's also a hard rock. Most of the phyllites have a compressive strength over 30 megapascal, which is better than concrete. So the support system would have been also different. So it depends on the culture and the way we build the tunnels, you know. So where you are and how, what kind of methods we use. And then also here in this geological figure, I see that the 3 vertical fracture zones, most likely they are not vertical. It should follow the foliation plane of the phyllite or meta-sandstone, in my opinion. So of course, there have been many investigations, and because of that, it would have been decided. But still, I do not believe on that. Okay. So, and as an alternative, I would have thought a little bit differently when I make a tunnel, because these rocks that we will be excavating are still hard rock, even though they are weak, slightly weaker than other hard rocks. So you see this, if I look here to the left side of the picture, which is existing design. So there is a shortcut lining with steel reefs, and we have permanent concrete lining here. So concrete corrodes over the time, you know. So if we have to repair this, this tunnel will be used for 100 years at least. So the concrete starts decaying after 40 years. So this solution will not give any possibilities to repair. So then the tunnel size will be reduced if we have another layer of the concrete. Instead, there is a alternative possibilities here. If we have this to the right side, if I show here, so we have a tunnel rock support with the shotcrete and bolts, and you may have also use steel tips if you like in the weaker part, but it is not necessary everywhere. And then we could have this waterproofing membrane, and then to use this concrete panels instead of having full concrete lining. So then these panels can be removed, and the new panels can be installed again after 40-50 years. So then this tunnel would have been for a very long period for the society. And still, when we took off this panel, so it is possible to have extra layer, 5-10 centimeter of extra layer of shotcrete. So that would have increased the life of this tunnel, in my opinion. So this is an example of how we can make such possibilities. So for example, we have this spread concrete or shotcrete with systematic bolting to the right side. While excavating the tunnel, this support has to be anyhow placed, so that can be used as a permanent support for tunnel support. And then as a safety requirement and other requirements to fulfill, so we could have used these concrete panels, and it by doing that, it is much faster and much easy, and it is possible to replace. There are many benefits of this solution. So this is what I would have thought if I was asked earlier. So this is what I wanted to comment. Thank you very much.
Thank you very much, Professor Panti, for your recommendation and valuable comments. It was truly enlightening. As you have a long research background in the field of tunnels, we hope your expertise will surely be helpful for us in the days ahead. Now, with all these commentaries, we would now like to move to question answer session. For moderating the question answer and discussion session, I would like to invite Engineer Tuklal Adhikari to the panel. Engineer Adhikari is a senior member and the immediate past president of Nepal Geotechnical Society. He is the managing director of ITECO Nepal and a local partner of the consulting engineers for the Nagdhunga tunnel construction project. He is also an active member of Nepal Tunneling Association. Engineer Adhikari, I pass the mic over to you and request you to moderate the question answer session. You have about 25 minutes, sir.
Good afternoon to all. So my role here will be mostly to moderate this question answer session. So I think it was a very interesting webinar. We had very good presentations from the client side, presented by Kalpana Adhikari, and also from consultant side, design and supervision consultant, Nipun Koi. So these presentations were the basis for today's webinar. And then, of course, we had these three very eminent personalities in different fields as panelists. First one was Dr. Gangalal Tuladar, former Education Minister of Nepal. And second one was Dr. Pawan Kumar Shrestha, who has extensive experience in tunnel, mostly in hydro tunnels, but also some exposure to road tunnel. And then we had eminent professor, Dr. Krishnakanta Panthi, with extensive experience in academics, research, and also in the field of tunneling and geotechnical aspects. And it's an inspiring personality to many geotechnical engineers and tunnel engineers in Nepal too. And so with this, I think we had a lot of enlightening sort of thing. Many things were presented here. So I think in the, I will not take much time just like that. I wish to get questions from participants. I guess there are more than 100 participants here. So please, you can raise your hand and then ask a question, and participant can put questions in 2 minutes, and then I think answer must be addressed to one of the presenter or panelist, and then the respondent, presenter or panelist will have 3 minutes to address that question. So, let us see if there are any questions. Has anybody raised hand?
I think there are questions on Q&A if you look right there, and then just tell us.
In the Q&A.
Yeah. If you click there and then look on the questions, there I think there should have been many questions. I could see 61 there comments or questions.
One question was, what is the design speed of vehicle in the tunnel? So that I think Kalpana ji can address this thing, I guess, quickly.
40 kmph हो सर डिजाइन स्पिड टनल भित्र
14 kmph. Okay. So the entire road is for 30 to 40 kmph. So this tunnel is designed for higher side of that one. I think that is the way it should be there. And then, well, there are some questions from, well, this is a very first road tunnel, and there is a lot of expectations in the part of young engineers and young geologists. And they're looking for opportunities in getting trained or getting exposure from the project. So if there are any such opportunities to be extended to those young engineers and geologists, so I think from client side again, Kalpana ji can put something, and of course I can tell something about the capacity building part. If Kalpana ji.
अब यसमा चाहिँ मैले के मात्र भन्न सक्छु भने सर अहिले चाहिँ के इन्जिनियर्सहरु डिआर को तर्फबाट उहाँलाई ट्रेन गर्ने भन्ने छ हैन यो टेक्नोलोजी ट्रान्सफर एउटा यो कन्सल्टिङ सर्भिसको पार्टमै पनि भएको हुनाले अब बाहिरबाट कोही इन्ट्रेस्टेड हुनुहुन्छ भने अब कतिपय चाहिँ प्रोजेक्ट पनि गर्छु भनेर आउनु भएको छ उहाँलाई पनि हामीले फेसिलिटेट गरिरहेका छौं इन्फर्मेसनहरु दिएका छौं हैन अब त्यो बाहेक एउटा प्लान वेमा गर्न सकिन्छ जस्तो लाग्छ डिआर सँग कोल्याबोरेट गरेर मेरो विचारमा अझ यो प्रश्नको जवाफ मैले भन्दा पनि अर्जुन थापा सर हुनुहुन्छ हाम्रो डिडिजी सर उहाँले अझ बेटर वेमा भन्नुहुन्छ होला जस्तो लाग्छ
May I comment little bit on this issue?
Yeah,
Please.
sure, sir.
Yes.
So the Tribhuvan University has decided to have a master's education in rock and tunnel engineering in Pokhara. So there is a new batch. They will be starting from. There will be a inauguration on Monday. So there will be a full-fledged master's education in rock and tunnel engineering. So because we will be having quite a lot of tunneling activities in future in Nepal. So this is the most important education that our engineers must have. So I hope many who work in the tunneling field, they will contribute. And from Norway, we have a strong collaboration with IOE, and we'll try our best to help them before they become independent and to become more research-oriented institutions. So, and I expect that many consulting companies and especially Department of Road should be very proactive and help Tribhuvan University to enhance right education that is suitable for Nepal. We should not copy the design from Japan or Norway or America or Canada or other countries. We should build our own method that is so important for our geology that will address. Our geology is different than others' geology. Okay, so it is not similar. We should know that. So therefore, our engineers should be capable of dealing with our rock mass. So therefore, I expect that Department of Roads becomes very proactive and they can send their engineers for master's education in that program. Thank you.
I would also like to have add a couple of things on this.
Can I add? So can I add something on this matter?
Yes, please do.
Yes, sir. First of all, I would like to thank Dr. Panthi for opening up new course or new curriculum in tunnel engineering in Pokhara University. Sorry, Pokhara Western Region Engineering College. And we will be happy to collaborate with Tribhuvan University and any other universities in Nepal. And we are planning to conduct different trainings for Department of Road Engineers, mainly the DOR engineers in this tunnel. And we are planning to train almost 50 to 60 people in this tunnel. So in every 2 weeks, there will be some coursework and demonstration work for this tunnel. And our Japanese colleagues are eager to help us. Some theoretical aspects will be dealt by the tunnel Nepal Tunnel Association members. So we have contacted some of the people, members of Nepal Tunnel Association and Geotechnical Society as well. So these two organizations will be collaborated for the training, and Japanese supervision team as well as the contractor will also help us during the training. So so that after the completion of this tunnel project, new pool of engineers will be there with enough knowledge for the construction of new tunnels in Nepal. Thank you.
Thanks. So there are other questions.
Can I ask? Can I add little thing on this?
Okay, sir. Please do.
Yeah, I agree with the Kishore Arjun Thapa sir's idea that DOR will be sending its engineers for the training. I'm also affiliated with Nepal Tunneling Association, and together with staff, we already have given a couple of training courses to civil engineers in Nepal, particularly in road tunnel design as well. So there are already inbuilt courses organized by SCAF and NTA, Nepal Tunneling Association. in addition to that, we are also affiliated with this WRC Western Regional College for MSc in tunnel engineering. So we are the resource person. And then there are also other courses as well, you know, which may be very interesting, particularly in IOE and Trisandra and TU. They are offering, you know, courses like, you know, they are not exactly full-fledged master's course in tunneling, but, you know, courses on tunneling are also offered in Kulcho campus, and then in TU as well, engineering geological master's degree. There they have, you know, a very good curriculum on tunnel engineering. Not only in TU, it is also in TC. So students can benefit a lot from, you know, the courses. So that is what I want to share. Thank you.
Thank you, sir, for clarifying this thing. There are some more questions from Facebook Live also. There is, well, I think it's compiled by Mandip Subediji. So the question is related to this evacuation tunnel. So the question exactly is, how is the evacuation tunnel closed? I mean, how is it connected with main tunnel, and how many connection points will there be? And what will be the evacuation, and what will be the evacuation? Well, something missing there. So, so the question here is, the evacuation tunnel, will it remain there as permanent, or will it be only only facilitating the main tunnel construction during construction period, or will it be maintained for entire service life of tunnel? So that is the question, I think. So I think Kalpanaji can very well give the answer. Kalpanaji, please.
Yes, sir, it is also a part of like tunnel operation. किनभने हामीले if anything, any emergency comes during the operation of main tunnel, then the rescue team or the passengers themselves can travel through the evacuation tunnel, and at every 375 interval, there is a cross passage of around, I think it's a 4-5 meter width. So it will operate parallelly. It's open. The gates are both the tunnels are connected by a cross passage with gates.
Okay, thank you, Kalpanaji. It should be viewed as an integral part of the tunnel system, yes, and it must be there for entire service life of the tunnel. This is the purpose of evacuation, because evacuation is necessary throughout the length of tunnel if there are accidents or fire hazard or other things. So it should be there. It's integral part of the tunnel system here. So obviously here in this case, there is only one main tunnel with through lane and one evacuation tunnel. So another alternative was proposed by our eminent professor, Krishna Kanta Panthi sir, that it would have been with the design traffic of 13,000 vehicles per day. It would have been better to have two twin tube tunnel. In that case, evacuation tunnel is not separately required. So one tunnel serves as evacuation for another. So there must be, of course, cross passage in between in intervals, but two tunnels would serve as a traffic tunnel as well as for evacuation for another tunnel. So that is not the case in this one. So this evacuation tunnel should remain there operational all the time during the design life of the tunnel. So that is...
Tuglal sir, here are some people raising the hands. I think we have few minutes more. So I am allowing the participants to speak. First, I want to allow Amod sir, Amod Dixit sir.
Amod sir.
Thank you very much. This is this is a great conversation going on, and I thank our DDG and all the known persons here. Just to add to Professor Panthi's observation regarding the twin tube, I remember that in Norway, the twin tubes are used for several tunnels that bring in bauxite from other locations all over the world, or mainly from Brazil, and the trucks going down hills. So the standard of the two tunnels, the two tubes are different. One for bringing in high load. So I was just wondering, see, in case of Kathmandu, the traffic coming into Kathmandu, it is heavily loaded, sometimes more than what is allowed. But while going back, it is almost like, it is very empty. So that would have added some value if you make the differential standard in the two tunnels. But that is just my observation. My one perhaps concern is, I mean, if I understand correctly, I have not looked into the geological, just what was flashed just now by Kalpanaji. What I see is that there is some stretch going in Sept formation, and also in some other, even in Tistung formation, you get pockets of this calcareous rock limestones, and there is a possibility of encountering sudden, gushes of water, underground streams there, as we have seen in, I remember one small tunnel in Mistri Khola near Dana, and that was the problem. I looked into that tunnel way back, I don't know, maybe 20 years ago, and then the gushing of water was really, it was a problem. So I'm just flagging my concern. It may be a foolish concern, but then just I thought that I should do that. But thank you very much for organizing this wonderful session. Thank you very much. Bye-bye.
Thank you, Amod sir, for your very enlightening type of comment. Regarding this water concern, I think there was a lot of concern in the design investigation team, and they had, in the vertical holes drilled for the investigation, piezometers are installed and water table monitoring is made. And then based on that, this will be continued, monitoring of water table will be continued during the construction period, as well as some year during tax liability period. And of course, there is anticipation that there is some water will be shipped out from the weep holes in the tunnel, and that water is again, in one, this is a loss of water from groundwater, and that may result in some deficiency of water in the springs. So to compensate that, the project has made adequate provision to collect that water and provide the water supply to those communities as well. So that sort of thing is taken care of, sir. So if there is...
May I add a little bit?
Okay, sir, please.
So yes, the comment is very correct, and of course it should be correct. There may have been some pockets of water that may be hitting the tunnel, but I am sure there is a plan to have probe drilling ahead of the tunnel construction if the geological formation is changing. So especially phyllite and sandstone bands. So phyllite always hinders water to leak, but sandstone carries the land because the water, because it has this brittle nature. So through the joints of sandstone, water may come, but the layer of phyllite hinders water. So, and then if these both parallel layer are hitting one after another in one of the formation, there is a possibility to hit some leakage, but not extensive, I believe, because there are no any rivers or something like this that feed permanently for the water seepage. But during monsoon period, some water seepage may increase, of course. So, but there should have been some plan to, in that case, to have a pre-injection grouting or something like this, I believe.
Thank you, sir, for clearing the point. I think it was very helpful for the project to note it. Well, one major thing concern of the participants and question, well, somebody who put question is that it's this tunnel is only for 2 lanes, and traffic in the highway is 13,000 vehicles per day. So if that is the volume of traffic, so will that entire traffic be passed or taken by the tunnel, or what percentage of that traffic is expected to use the tunnel? I guess, I think there are some certain criteria for vehicle to pass through the tunnel. It must be some certain Euro standard specified in the requirement. So if there is some exact information, so Kalpanaji, can you share something?
Yes, sir. The total number of estimated traffic in 2030 is 13,000 vehicles per day. And it is assumed that 75%, almost 75% of traffic will travel through the tunnel, and remaining 25% through the existing road. And what was the question? I just forgot.
There is a specification that there is some pollution level, emission control.
Yes, there are some restrictions. I also mentioned in my presentation as well. There are some restrictions to the vehicles, like the vehicles carrying explosive materials cannot pass through the tunnels. Overloaded vehicles cannot pass through the tunnels, oversized. So considering all these conditions and the present traffic patterns, it is assumed that 74–75% of vehicles will pass through the tunnel.
Thank you, Kalpanaji. I think I should
shall I show one slide? Shall I show one slide in this?
Okay, please do, sir.
Yeah, how we this? What is the standard, normal standard? I'm referring to the Norwegian road standard. Professor Panti is there, so he will guide us. But let me show one slide, okay? Okay. So if you see here, so this is from the Norwegian road standard, right? And to my knowledge, earlier we thought that the Nagdhunga road tunnel would have hardly 10,000 AADT, but as Miss Kalpanaji is showing that saying that is 13,000, and our tunnel is in this range. That means we have to have about two tunnels of 8.5 meter diameter. This is according to Norwegian road standard. Had it been so less than 10,000, we would have hardly one tunnel of 9.5 meter diameter, and then some evacuation. But the number of traffic would rather increase than decrement. So I believe for instance our range should be somewhere here 8.5 or 8.5 or 9.5, having with 8.5 and 9.5 number of tunnels, two tunnels. So we should have chosen either this or that, preferably 9.5 for future. But this 8.5 for as of now, for at least up to year 2030, that we should have had two tunnels, but for bidirectional, unidirectional, two tunnels. Unidirectional, two tunnels. So two for going down, two for going up. But as you might have thought that they have this additional road, the existing road that can be used to lessen, to reduce the number of traffic, so that people going down from Kathmandu to Novi can still use the existing road. So in that way, the number of vehicles can be reduced. But it is to the DOR or designers who they know what is the basis of choosing the number of tunnels for this Nagdhunga road tunnel. Thank you.
So a little bit comment, since we have already decided to build this tunnel and we have this evacuation tunnel, the evacuation tunnel would have been expanded to a new tube. It does not cost much. You have to do all this For the evacuation tunnel, you should have all the support and concrete lining and everything. So it will cost quite a lot of money. So government should have discussed about it, and then instead of having evacuation tunnel, it would have been made a new tube tunnel. So that will make life much easier for Kathmandu for future many years to come. So still, I think the road department should think about it.
Thank you, Professor. So that was discussed at length during investigation and design. There was feasibility study, and then there was detailed design. That time also these things were discussed many times, and it was the decision made earlier. So I'm not sure whether this can be taken up by DOR within this project or not. So that I think will get answered. Deputy Director General from the DOR, who is present here. So I think he will throw some light on
मलाई एउटा कुरा एड गर्न मन लाग्यो हुन त यो मैले DOR-कै पर्सपेक्टिभबाट भन्दा पनि पर्सनल्ली के भन्न मन लाग्यो भने हामीसँग अल्टरनेटिभ रुटहरू बनि पनि रहेको छ, जस्तो फास्ट ट्र्याक बनिरहेछ, हेटौडाको सडकहरू बनिरहेछ हैन, अनि त्यो वेमा चाहिँ ट्राफिक भएको भएर यो सफिसिएन्ट हुन्छ भनेर सोचेको हो कि जस्तो पनि लाग्छ है।
कल्पनाजी यस्तो हो, कस्तो छ भने हामी नेपालीहरू पनि त डेभलप हुँदैछ हैन। पोखराबाट काठमाडौँ आउने मान्छेको नम्बर त्यतिकै इन्क्रिज हुन्छ, काठमाडौँबाट पोखरा जाने मान्छेको नम्बर त्यतिकै इन्क्रिज हुन्छ। त्यो त मेन ट्रङ्क रोड हो नि त पोखराको लागि त एटलिस्ट। ल पूर्वको भेहिकल ल तलबाट आउला फास्ट ट्र्याकबाट हैन, पोखराको मान्छे त फास्ट ट्र्याक हुँदै आउँदैन। इट इज भेरी इम्पोर्टेन्ट रोड, very very important road. Even if we open new tunnels, new roads, still this is the main road. This is the main road, and traffic will be exceeding by 2040 at least 20,000.
Thank
you sir for your view. एउटा इन्टरप्ट गरे, यो छ नि मसँग एउटा डेटा पनि छ, त्यो एनुअल एभरेज डेली ट्राफिक नागढुङ्गाको लागि मसँग त्यो 10,000 को डेटा थियो। अब कल्पनाजीले चाहिँ 13,000 भन्नुभयो, यो अपडेटेड गर्नुभयो कि मसँग चाहिँ भएको, जस्तै फर इक्जाम्पल मैले अहिले देखाएँ भने यो मसँग भएको डेटा चाहिँ यो, यसमा चाहिँ हार्डली 2030 मा 10,000 देखाइरहेको छ। अब यो प्रोबेबली त्यो चाहिँ अब उ हुन सक्छ, के भन्छ तपाईको यो कि सर्वे नै रङ, अथवा यसले अपडेट गर्दाखेरि 13,000 पुगेको हो कि ड्रामेटिक।
सर यो यसको तलपट्टि अर्को टेबल छ सर, यो चाहिँ नि टनलबाट पास हुने भेहिकल्सहरुको ट्राफिक हो। 13,000 चाहिँ इन टोटल हो हैन, टनलबाट जाने भनेको 74% 75% चाहिँ अज्युम गरिएको छ। 2030 मा टनल रुट प्रयोग गर्ने भनेको 10,000।
यो कन्टेक्स्टमा हेर्ने हो भने ल डिजाइन रिक्वायरमेन्ट कुरा चाहिँ ठिकै होला, तर अब ह्याभिङ सेड द्याट अब हामीले अलिकति बढी त जहिले पनि सोच्न सक्छौँ नि, किनभने 5 डायमिटर सुरुङ चाहिँ अब 9 मिटरको गर्न चाहिँ खास महँगो पनि पर्दैन। अब तपाईले 5 अर्ब रुपैयाँ उसमा खर्च गरि नै सक्नुभयो, त्यसैले नै त्यो ल्यान्ड एक्विजिसनको लागि त्यसैले नै चाहिँ कभर भइहाल्छ। पोर्टल स्टेबिलिटीको इस्यु मोरलेस सेम हो। अनि त्यसपछि यो जुन चाहिँ यो स्पेसिङको कुराहरु अलिक टेक्निकल एस्पेक्टहरु अलिकति रिभ्यू गर्नुपर्छ, किनभने डिटेल इन्जिनियरिङ जस्तै अब इन्भेस्टिगेसनहरु मोरलेस दुईटैको लागि भइ नै सकेको छ। पोर्टल त्यही नै हो भनेपछि अलिकति फेयरली लार्जर गर्न सक्यो भने के हुन सक्छ भन्ने एउटा मात्र कुरा हो। र त्यो जुन चाहिँ क्रस प्यासेजको जुन चाहिँ लेन्थ अथवा चाहिँ स्पेसिङ चाहिँ त्यसको स्टेबिलिटी एक्चुअली इभ्यालुएसन गर्नुपर्ने हुन सक्छ। एउटा अब
I give you an example. I give you an example. We have 4 tunnels from here to the airport in Trondheim. So these were single tube tunnels built in 1990s. So that time government decided to reduce the expenses and have decided to have one single tube. But now the traffic has increased so much after 15-20 years. So then there is they have to build new parallel tubes, which will cost 3 times more than it would have been in 1990s. So therefore, since we have to have this evacuation tunnel. So I think that the best is it is expanded, and if there is no loan coming from Japan, government should invest internally. This is very important road. It won't cost much, and we will save quite a lot of money.
For your suggestion, I think DOR will take a note of it, and they will decide on the strategy, what they have to do. Well, that I should close because of time. One thing I just want to put one thing is that we have fast track coming very soon, and that will have twin tube tunnels, and that will be 4-lane all through from Tarai to Kathmandu. So that will take central and eastern part traffic totally, almost totally. So with that, we'll be left with western traffic only. So this even 10,000 may not be the case in actual traffic volume. So with that note, I think our time has gone. So I
sir, 1 minute.
Okay, sir. Please.
1 minute दिनुहोस् भनेको.
Please.
के अरे हैन मैले ओभरअलमा एड्रेस मात्रै गर्न खोजेको, मेरो एउटा कन्सर्न मात्रै. एउटा चाहिँ फर्स्ट कन्सर्न चाहिँ टनल प्रोजेक्ट यत्रो बिग प्रोजेक्ट गइरहेछ हाम्रो, एउटा भनौँ म्यासिभ, हामीले नेपाली गभर्मेन्टले सायद नचाहँदै पनि हामीले अलिकति खर्चिलो प्रोजेक्टमा हात हालिरहेको छौँ. त्यसमा चाहिँ मैले यो लर्निङ स्टुडेन्ट्स र यिनीहरूको लागि त डेफिनेटली हामीले कुनै न कुनै फिल्ड पाइहाल्छौँ. त्यसमा त एकदमै मलाई चाहिँ इन्ट्रेस्ट केमा छ भने, मेरो पर्सनल इन्ट्रेस्ट, भोलि हामीले त्यो प्रोग्राम सडक विकास पनि गरौँला. स्टुडेन्ट्सहरूलाई, स्कुल स्टुडेन्ट्सहरूलाई चाहिँ, स्कुल चिल्ड्रेनहरूलाई एकदमै इम्पोर्टेन्ट छ यो भोलि फ्युचरको लागि हामीलाई. हाई स्कुल स्टुडेन्ट्स र एलिमेन्ट्री स्कुल्सदेखि सबैलाई, बरु यो सबै स्कुललाई भ्याउन चाहिँ सकिँदैन है, तर बेसिक नम्बर जस्तो 100 स्टुडेन्ट्सलाई हामी प्रायोरिटी दिएरलाई चाहिँ जसलाई देखाउनै पर्ने हुन्छ त्यो प्रोजेक्टहरू हामीले. किनकि यो जापानमा पनि हुन्छ, अरू विदेशी के अरे डेभलप नेसनहरूमा हुने ठाउँ हो. यो स्टुडेन्ट्सहरूलाई हामीले कुनै न कुनै सडक विभागले यत्रो काम गरिरहेछ भनेर देखाउन अपिल गर्नुपर्ने छ. एउटा कुरा चाहिँ त्यो पनि गरौँला. अर्को चाहिँ अहिले कृष्ण पण्डित सरले पनि भन्नुभयो, त्यसपछि अरू कुराहरू पनि आए. यो काठमाडौँ पोखरा, यो चाहिँ इन फ्युचर कुनै न कुनै बेलामा 4-लेन रोडमा डेभलप हुन्छ, त्यसको कुनै शङ्का छैन. एउटा कुरा. अर्को कुरा चाहिँ हामीले 10-20 वर्षमै हामीले चाहिँ 50 वर्षको प्लान गर्नुपर्छ भन्ने पनि छैन. हाम्रो कन्टेक्स्टमा चाहिँ त्यो अलिकति गाह्रो छ, किनकि हामी इकोनोमिकली यही प्रोजेक्ट गर्नलाई हामीलाई त्यो 10 वर्ष लागिरहेछ. त्यही भएर म चाहिँ अलिकति कृष्ण सरको उसमा चाहिँ अलिकति काउन्टर गर्न किन चाहन्छु भने, अहिले नै हामीले 20-30 वर्षको प्लान गरिहाल्नुपर्छ भन्ने पनि छैन, किनकि 13,000 ट्राफिक भनेको त्यति खास हेभी ट्राफिक पनि होइन जस्तो लाग्छ मलाई अझै पनि. अब भोलि गएर त्यही ठाउँमा अर्को टनल पनि बन्न सक्ला. त्यही भएर अलिकति यसलाई चाहिँ यो अनगोइङ प्रोजेक्टमा गइसकेका हुनाले अलिकति चेन्ज गर्न सायद मेरो विचारमा अन द पार्ट अफ डिपार्टमेन्ट अफ रोड्स भेरी डिफिकल्ट. र यो वैदेशिक लोनमा बनाइरहेको हुनाले एउटा फर्स्ट अटेम्प्टमा चाहिँ केही न केही कुरामा हामीले कम्प्रोमाइज पक्कै पनि गरेका छौँ. त्यही भएर अलिकति क्रिटिकल त हामी सबैमा हुनैपर्छ, त्यो क्रिटिकल्ली हामी जानै पर्ने हुन्छ. र मेरो विचारमा अबको भनौँ न 2030 अथवा 2040 पछाडि चाहिँ यदि हामी 4-लेन रोडमा जानुपर्ने हो भने विल ह्याभ प्रोबेबली नेक्स्ट टनल, अर्को सेकेन्ड टनल पनि त्यही आउन सक्छ. भइदिएको यो वास्तवमा यहाँलाई थाहै छ होला, मेरो विचारमा 3वटा के अरे 3-लेन टनल बनाउने प्लान थियो पहिला, पछि चेन्ज भएछ. मलाई पनि यो अलिकति बिचमा पछि थाहा भयो. 3-लेन टनल भनेको चाहिँ काठमाडौँ आउने चाहिँ 2टा लेन, जाने चाहिँ एउटा लेन भन्ने थियो. अब अहिले पनि मेरो विचारमा 40 km/h भनेको चाहिँ अब एउटा स्ट्यान्डर्ड मेन्टेन गर्यो भने त सायद 40 km अपग्रेडमा आइहाल्ला. तर अझै पनि गाह्रो देखिन्छ त्यहाँ चाहिँ. त्यति खास पुग्न 4% छ ग्रेड चाहिँ. त्यो भनेको चाहिँ जापानमा भन्दाखेरि लगभग एक्सप्रेस वेको ग्रेड हो, राम्रै हो. तर अब जस्तो 60 किलोमिटर्समा डिजाइन गरेको भए 60 किलोमिटरमा भएको जम्मा 3 मिनट्समा हामीले पार गर्न सक्थ्यौँ. अब 3 मिनट भनेको त धेरै सर्ट हो डिजाइन. त्यसको लागि मेरो यो कमेन्ट होइन कि, मतलब एउटा आइडिया, एउटा मात्रै हो, कन्सर्न मात्रै. थ्याङ्क यू भेरी मच.
I think if there are no other questions, I think time is running out. So I pass the mic to Santaji.
Thank you to Class sir for this very lively question, answer and discussion session. It was very interactive. Thank you all the speakers and commentators for your response, for clarifying the queries. We are now almost at the end of this webinar. Before we end this program with the closing remarks, I'd like to thank you all again for bearing me and my limitations while running this program. I have tried my best to deliver my abilities. Thank you all for your kind support and patience. With this note, I would now like to invite Engineer Arjun Jang Thapa, the Deputy Director General of the Department of Roads, to put forward his comments and deliver the closing remarks, and also declare the end of this program. Thapa sir, the mic is over to you, sir.
Thank you, Kusaltaji. And first of all, Engineer Netra Prakash Bandari, President, Nepal Geotechnical Society, Kalpanaji, our engineer for this project, and Mr. Yoshihiro Nojo, engineer from Nippon Koi Limited, Japan, and we are eager to welcome you in Nepal. So and we have processed your processed your permission to travel to Kathmandu during this COVID locked situation. So perhaps by next week you can arrive here. And Honorable Dr. Gangalal Tolar, former Minister for Education, and Dr. Pawan Kumar Shrestha, Hydro Tunneling and Resource Private Limited, Nepal, and Professor Dr. Krishna Kumar Panthi from Norwegian University of Science and Technology, Norway, and moderator Tuklal sir, with whom we are working together in this tunnel and in many other projects in Nepal, just like Mugli Narayan Ghat slope stabilization project and many other projects. So it's my pleasure to be here in this webinar. And I want to extend my sincere gratitude to all the experts from different fields, mainly Netra sir, and Dr. Pawan Kumar Shrestha and Dr. Panthi, and even Tuglal sir. So actually, we need a wider consultation among various stakeholders, and we may be lagged in this situation. So there was, I think, with the verdict of Dr. Panthi, it is clear that there was the lack of wider consultation among various stakeholders and various experts. So we will try to consult in a wider participation in upcoming projects. There are many upcoming projects link. One is Siddha Baba Tunnel, experts mainly from Tribhuvan University and some consultants working in Nepal, and actually there are 6 or 7 projects proposed for construction in Nepal. The government of Nepal is trying to construct or planning to construct Siddha Baba Tunnel, Tokha Chhare Tunnel, which links Kathmandu with Roswagari and the Chinese autonomous region of Tibet from Kathmandu. And the third is Chiabari Khurko Tunnel, which links Chiabari in the Sinduli Madi and Khurkot in the Khurkot at the Sunkosi Valley. And similarly, there is a proposed Downey Tunnel, and one tunnel is being investigated, designed, which is assisted by Swiss Development Corporation, SDC. This is in Thankot Chitlang Road. And we have also studied for several small or short tunnels in Siddhartha Highway. There shall be some 7 or 8 very small tunnels, just like 300 or 200 and 300 meters short tunnels to shorten the length of the Siddhartha Highway. By introducing 7 such tunnels, the length of Siddhartha Highway will be shortened by 12 kilometers. The length of the tunnel will be less than 2 kilometers. The length of the road shortened would be 12 kilometers in Siddhartha Highway. So government of Nepal, our department, mainly Department of Road, has such type of short tunnels. And we have also studying that is in a preliminary stage for Kusma and Pokhara tunnel. That is underneath Lumle. And actually there are 2 more tunnels which were constructed by Nepal Electricity Authority. One was Bulbule tunnel in Lamjung, and which is being used by the general public. And another tunnel is in Dolkha, which was constructed by Upper Tamakosi Hydroelectricity Project. It was constructed in 2016. And FASTAC has planned to construct 3 tunnels. The total length of these 3 tunnels will be 6.5 kilometers in Kathmandu Tare fast track. And now the era of tunneling has already come, and we are planning in this aspect. Actually there were no such experts in Department of Roads, and we are planning to establish a separate section for tunneling in Department of Roads, and we need that. And we want to establish a pool of experts who will be working in tunneling only. So regarding this the tunnel bore machine, so Department of Irrigation has already used tunnel boring machine in Baby Borbai diversion scheme, and they are also planning to utilize the TBM for Sunkosi marine diversion as well. And if we are able to construct more tunnels, or if our budgetary system and some capital investment is sufficient for us, we will definitely plan new tunnels, and we will definitely utilize TBM in longer tunnels. And so in the end, I would like to thank all the dignitaries, experts from different sectors in tunneling, and Dr. Panthi, who is with us from Norway. So thank you, Dr. Saab. And I would like to thank all other engineers, and most of the questions which were asked in question answer, I have answered them. Most of the questions are already answered by me. And so with this, I would like to conclude this webinar. Thank you.
Thank you very much.
Thank you. Dhanyavad. Namaste.
Dhanyavad sir. Namaskar.
Yes.
Thank you.
Thank you for inviting me, of course.